Balancing redox reactions using oxidation number method. So this time we are balancing the redox reaction in the basic medium. This reaction takes place in the basic medium. So we can begin. What is the first step? Write the equation correctly. We have already written it. This is permanganate ion, bromide ion, manganese dioxide and bromate ion. Okay. The next step is to assign oxidation number. So how will you assign oxidation number? Oxygen atom we already know it is -2. How will you assign the oxidation number of manganese? It's very easy, okay. The algebraic sum of the oxidation number of the species must be equal to the charge of that ion, if it is an ion. So, let the oxidation number of manganese be x. X plus 4 into -2 minus 8, that is equal to -1. So, x is equal to -1 plus 8, that is plus 7. Oxidation number of manganese is plus 7. Now bromide is already -1, equal to the charge. Manganese dioxide is a neutral species. Okay, this is not an ion. For a neutral species, the algebraic sum of the oxidation numbers of all the elements must be equal to 0. So for oxygen, as usual, it is -2. We can take it as x plus 2 into -2 minus 4, that is equal to 0. So x is equal to plus 4. The oxidation number of manganese is plus 4. Now what about bromate ion? Bromate ion, as usual, it is an ion. So -2. The charge is -1. For bromine, let the oxidation number be x. There are 3 oxygen atoms, so 3 into -2 minus 6. So x is equal to -1 minus -6, that is plus. Identify the atoms that undergo oxidation here. Have a look at it, children. Which are the elements that undergo change in their oxidation number? Oxygen, it is -2 everywhere. What about manganese? For manganese, the oxidation number decreases from +7 to +4. So this is reduced. Next, for bromine. For bromine, the oxidation number increases from -1 to +5. Here the oxidation number increases, so it has undergone oxidation. Now what is the next step? We have identified the elements that have undergone oxidation. They are manganese and bromine. Manganese and bromine. Let's balance the number of manganese and bromine atoms on the reactant as well as on the product side. Manganese, here it is 1, here also 1, balanced. Bromine, here is also 1, here is also 1, balanced. Okay, oxygen atom will be balanced at the end, not now, in the last step. Now, our steps are not over. Calculate the total change or total decrease or total increase in the oxidation number of both manganese and bromine. We can start with the manganese. total change in oxidation number of manganese. So on the product side it is +4 minus +7, so that is equal to -3. Now what about bromine? It is on the product side +5 minus -1, that is 5 plus 1 is equal to 6. Remember, when we calculate the total change in the oxidation number, always subtract the oxidation number of the reactants from the products. So the product side it is +5 minus -1, otherwise there will be a change in the calculation. You will get a different answer. Okay, so now we have got the change in the oxidation numbers. -3 and 6. Now next step is to find the simplest ratio. Divide both 3 and 6 by 3, you will get 1 and 2. Here, the total change in the oxidation number of manganese must be equal to bromine. Here it is 2, but here it is 1. So in order to equalize it, we need to multiply the manganese terms by 2. So here 2, on the reactant side also we need to put 2. So the oxidation number part is over. We can rewrite the equation once again. Our next step is to balance ionic charges on the reactant as well as on the product side. So how will you calculate the ionic charges? Here for permanganate ion the charge is -1, but there are 2 permanganate ions. So the charge on the reactant side will be equal to 2 into -1, plus for bromide it is -1 charge equal to -3. Now here on this side, manganese dioxide is a neutral species, no charge. For bromate ion, there is a -1 charge. So here the ionic charge is -1, here the ionic charge is -3. How can we equalize it? Whenever you want to equalize the ionic charges, and I add either H plus or OH minus ions. But this is taking place in the basic medium. If it is taking place in the basic medium, we need to add OH minus ions. Okay, hydroxide ions. So our question is, where will we add the hydroxide ions? Here there is -3. Here there is -1. We need -2 charge here. Okay, for that we need to add 2 OH minus ion on the right hand side of the equation, that is on the product side. On the reactant side already the ionic charge is -3. Why we need 2 more negative charges, for that we will put 2 OH minus ions here. Remember, the reaction is always taking place in aqueous solutions. Next step is balance the hydrogen and oxygen atoms. Either you can take hydrogen or you can take oxygen atoms. We will balance it by adding water molecules on either side or on the appropriate side of the equation. So let's see. Calculate or count the number of hydrogen atoms here. Here there is no hydrogen atoms. Here there are 2 hydrogen atoms. Alright. There are 2 hydrogen atoms here, but here is 0 hydrogen atoms. So in that case, in order to balance these 2 hydrogen atoms, we can add 1 water molecule on the reactant side. When you put one water molecule here, automatically it will become, there will be 2 hydrogen atoms. Now count how many oxygen atoms are there. Here 4 2s are 8. There is 1, so 9 oxygen atoms. Here 2 2s are 4 plus 3 plus 2. So 4 plus 3 is 7, 7 plus 2, 9 oxygen atoms. Oxygen atoms are also balanced. Now we can rewrite the equation if it is necessary. 2 MnO4 minus Br minus plus H2O giving 2 MnO2 plus Br3 minus plus 2 OH minus. This is a balanced chemical equation.